All right, so now we're going to look at multiplying imaginary numbers, and we're just doing the distributive property here. So we would have 2 times -4 is -8, and then 2 times -2i is -4i. Our inside terms here, we've got -3i times -4, that's going to be positive 12i. And then our last terms here, we've got -3i times -2i, so that's going to be positive 6i squared. All right, so some things that we can do here, we can combine our -4i and plus 12i, and that would give us positive 8i, and then -8, and then plus 6, but I squared is -1, so that's going to be -8 plus 8i minus 6, -1 times 6. Combine our like terms here, we've got -14 plus 8i. And we always want to leave our answers when we're writing our complex numbers, if possible, in the real part plus the imaginary part. All right, this one right here, something interesting should happen when we multiply this, and there's a pattern we'll talk about on the next page. All right, so 5 times 5 is 25. Our outer terms, we've got plus 15i, and then our inner terms, minus 15i, and then our last terms, we've got minus 9i squared. And we see that the middle terms cancel. They go to 0, so we've just got 25, that's 0, and then minus 9i squared. But what is I squared? I squared is -1. So we've got 25 minus 9 times -1, so that's going to be 25. Negative times a negative is a positive, plus 9, and 34. So this complicated looking multiplication simplifies into just a nice number, 34. And that's because of this pattern that we've seen many, many times before, that always causes those middle terms to cancel. A plus b, a minus b. We'll see that in the next page. All right, so if we have something like this where you have to square something, I'm not going to do this whole problem. I'm just going to remind you that it's probably easiest if you write it out. And don't think that you can just apply that squared to both.